Suppose we have this programming example. I have the variable x of type float equals 1 over float 3. I hope you remember what this means. Whenever you have a data type between parentheses, this is an example of typecasting. I'm converting the number 3, which is an integer in this case, to a float. And then I have double y equals 1 over 5.0. Right? So this is another way, instead of doing typecasting, to ensure that the result is a floating point number, you can just add dot 0. So if I output this, this is the output that I got. So x equals this number. Actually, the number 1 over 3 is 0.333 to infinity. But because it's a float, this is the maximum precision that it can store. So we got the number like this. Okay, now as for 1 divided by 5, the result is 0.2. If we had again here 1 over 3 as a double, see, we got 0.333 with a little bit more precision. This output is a little bit ugly and unpredictable. Let's say I want my output to always have 2 decimal places. So when I have 1 over 3, I want it to be 0.33. If it was 1 over 5, I want it to be 0.20. Right? So I want my output to be always consistent. With just print line or print, there's no way to do that. Right? The output will depend on the data type. We have another method in System.out called printf. This method allows us to format the output string. So it gives us control about how we want to print those numbers. Okay, so first of all, if you don't want to format the string, if you just want, okay, x is plus x, so you can use it the way you use print. See, we got the same output. So it's like print, not like print line, because it doesn't output a new line character, right? If we want to output a new line character, we have to do that manually, for example, using \n. Okay, but this, we don't want to use the printf method this way. We want to use it in a different way, which is the variable that we want to print, we add it as a second argument. So we will have comma x. Okay, so we want to print x, and we want to print it here at this location. So the way we specify that is using the % followed by f. What f means is a floating point number. So what I'm saying here, in this location, we have a floating point number, and that value is specified after the comma here. So see, when I printed this, I got this output. Okay, so far it doesn't seem like there is any advantage to doing this, but we can add something here. We can say dot 2. What I'm saying here is this floating point number should have only 2 decimal places. See, so I got the output as 0.33. If I say 0.1, I got just 1 decimal place, 0.3. Okay, let's take the original example, 1 over 5 for y. So this looks the same as the original output because we only got 1 decimal place because the number is exactly 0.2. But if we wanted to print 3 decimal places, it's just going to add zeros after that. So the output is 0.200. And we're not restricted to one variable here. We could print both x and y in the same string. So we could say x is, right? So what I'm saying here is, I have this string, it's a normal string, but at this location, I have a floating point number with 3 decimal places. And at this location, I have another floating point number with 3 decimal places. So then after specifying the string, I have to specify those variables that will replace this part of the string, right? So the first one, I want it to be x, and the second one, I want it to be y. They have to be in the right order. So here I got x is 0.33 and y is 0.200. If I did this in the other way around, I'll get the values swapped, right? So more generally, the formula for formatting a string with printf looks like this. We have a % whenever we want to print a variable, and there are 2 optional things we can specify and 1 thing that is required. It's called the conversion. This is a typo. So this is basically the type of the variable that we want to print. We saw an example with a floating point number, and that's f. So that's something that's not optional. We have to specify it. So we have other types. We have s for string, we have n for new line, and we have d for an integral data type. Some people find this confusing because d looks like a double, but no, it stands for decimal. So it's used for integral data types. Okay, and we have the option to add the precision for a floating point number. So, and the way we do that, before the type, we can specify dot and then the number of decimal places. We have a third optional thing we can specify, which I haven't showed you yet. It's called the width, right? So before the precision, we could specify a number, which is the width of that variable. And I'll show you an example of that. Here, there's a quick example where we want to print all types of variables. We have a string sentence. We have an integer called num, the value is 96. And we have a double rate, which has this value. Okay, now if we want to print all of these in a formatted way, we could do it this way. %s means we want to print a string here. %d, that's a decimal or an integral data type. And then here we have a floating point data type, and we want it to have 2 decimal places. And then we want to output a new line character. So the new line, we could do it like this as %n or \n. But keep in mind the % here is only meaningful with printf. With println, you cannot do this. Like if you want a new line, you have to use \n. So now let's say instead of typing x is here, I have this as a string. Let's call it s1 equals x is. We can put that as %s. And then here as the first argument after the format string, we can put s1. This gave us the same output. Now let's say y was actually an integer, right? And let's say the value is 5. Okay, so this doesn't work. We get a runtime exception because the value that you specify here has to match the variable type. So I could use casting here and make it a double, right? This would work. 5 was converted to a double. But if I actually want to keep the type as an integer, then I have to use d, %d, okay? And instead of \n, I could use also %n. Okay, now what about the width? So let's say here I add 10, right? So I'm saying the width of this variable is 10. And the width of this variable, I'll also make it 10. See what's going to happen. See, the space allocated for this variable is 10. So even though the value is actually, it's only taking these, 5. It only has 5 characters, right? But because I specified the width to be 10, then additional spaces were added for that character. The same thing here with y. This is useful when you want to output something in a table format. Let's say I change my first string to x is the value, right? So now it's larger than the second one. And let me change this format to 20. See, even though the strings have different length, because I made them have the same width in the format string, the output is still aligned. If I removed the width argument here, see now the numbers are not aligned because the strings are not aligned. Okay, so but notice that the alignment is adjusted to the right. It would be nice if we could adjust everything to the left. And the way we can do that is by making this a negative. So I'll make everything here negative. The space here is negative. Now the output is aligned to the left. Okay, in the next exercise, I would like you to output something that looks exactly like this. So I want you to output the strings and the numbers in a way that is formatted and aligned this way. So here everything is aligned to the right. You can also try just experiment with aligning things to the left.